VLPSos here. This is a video lesson for Python programming class. I recommend pausing on occasion to practice. We're going to import random at the top, make use of the random module. Now for some real power, the backbone of object-oriented programming. Get ready, Python has class. I'm going to introduce classes, an essential part of Python, very powerful and useful. My strategy is I'm going to introduce a lot of vocabulary concepts and ideas and provide a few examples. It may be overwhelming in the beginning to keep track of the new ideas and the new vocabulary. But if I introduce it first and then use it and repeat myself afterwards, then I think these ideas will sink in. So bear with me in the beginning. It might be a little overwhelming, but will clear up in the end and in the next few lessons. We want to think of data types as objects. They're not tangible, they're conceptual objects. We can't touch them, but they have properties. For example, a string we know to be a data type. But let's think of a string and what it means to be a string as a thing in itself, as an object, a conceptual object. This string has properties. And to note, this is a string. It has length, it contains characters, it's iterable, it behaves in a predictable manner when we add it to other strings, index it, when we use it with print. These are some of the string's attributes, the qualities that make a thing a string. There are many methods that work on strings, like capitalize, title, replace, many more. Strings are useful objects, but they're primitive. And we can make our own objects. Whatever we can think of, we can choose their attributes and write methods that work on them. That's what object-oriented programming does. Like the things that we can make in our programs. Adventurers that have health and items that we throw into adventures, rest and fish, sailing ships that have size and sails that we make race one another and gain prizes, Tweedle eggs that have color and age that we can hatch and grow and make more eggs, or if you're really into it, students who have classes and grades that can be calculated and adjusted. So in those lists of things, those examples, there were a description of what it means to be that object, that thing, sailing ship, egg, student, and then the things that we can do with those objects, like rest and fish and sail and race. When we think of things as objects and methods as the actions that we take with objects, then we have a conceptual framework to understand how we then might go about coding to accomplish something with those objects. So let's make something. We will start with the basics and explain as we go. I'm going to make, for fun, an adventurer. And as I do, this is going to be quite a bit of new code. We're going to type the code in and talk about it, but then refer and use these ideas quite a bit so that the newness wears off and we gain some understanding. But there's going to be a lot of new stuff from the beginning. I'm using a new keyword called class. My class is called adventurer, much like I would define a function and then name the function. Then in the code block of this class, so that what I'm writing in the code block belongs to the class, is the definition of a function. And this function is very particular, it has a very particular name, double underscore init, double underscore, and its argument parameters has the word self. And I'm using that word in a very particular way that deserves more explanation, to create an attribute. The attribute is health, and this is an attribute of the adventurer. So I'm thinking my adventurer, what it means to be an adventurer is to have health. I'm going to create another attribute called skill and assign it something I've made up as if listening is a skill. It certainly is. And then another attribute I'm going to call items and set that equal to an empty list. So it's possible to have items, but my adventurer doesn't have any items by default at the start as an empty list. Now let's provide some explanation of what this is. Class is a keyword much like def. When we use it, it's like we are creating a new data type. This would be data type adventurer. It is common to capitalize the first letter of the name of a class to distinguish it from functions. Naming convention, functions should be all lowercase, and classes should be capitalized, the first letter at least. And that way, when we read our code, we can distinguish between what is a class and what is a function. They're fundamentally different. Parentheses are used similar to functions, but we will wait on the how and why of their use. There is a function defined inside the class. I'm reading here. In fact, there are often many functions that are part of a class. Some functions are called methods, or such functions that belong to a class are called methods. The name of the function defined here is _init . The double underscores means this is a special method, one that is integral to the fundamental nature of how Python operates. Special methods are functions that are called not by name, but by some other essential process. $_init stands for initialize. That's what init means, initialize. It gets used when a new instance of the class gets created or initialized. And we use this word instance. We will quite a bit. So let's make a comment on what an instance is. An instance is a singular manifestation of the class that is its type. Is that clear? Think of a class as a general idea or a concept that describes an object, much like the idea of a ball or what it means to be a ball. Balls are round, made of certain materials, and are often used as equipment for a game. That's the qualities or attributes of what it means to be a ball. If you held a baseball in your hand, that particular baseball would be an instance of what it means to be a ball. That baseball is a type of ball. So an instance would be an actual particular object, manifestation, or creation, or thing that belongs to the idea or a set of things. Much like a particular baseball belongs to the set of the idea of what it means to be a ball. Now, we made our simple class definition has written what it means to be an adventurer, but we haven't made an adventurer object, or we haven't made an instance of an adventurer yet. A little bit more words. We created what it means to be an adventurer. Our adventurer has attributes: health, skill, and items. Notice that they all started with self. When we made them in the init function, well, let's take a look. We're told in this comment, health, skill, and items are attributes, and we set them to be attributes of what it means to be an adventurer in the init function. So here we are in the init function, and the attributes are the ones that we listed here. Well, we shouldn't have a space. So we have attributes, health, skill, and items. Continuing on with this comment, when we made them in the init function, we set them to be the attributes of the adventurer. Self is a variable whose value is the current instance the function is working with. So this self that was part of the name of the attribute is important for the language to distinguish the current instance that is being worked on, because it's possible to have many instances. So the program needs to distinguish between different instances, and it does that with that part of the variable that we've called self. We have yet to create an instance of an adventurer. We will do that now. Again, there is a lot being said and introduced. We need to practice and reiterate these ideas for your better understanding. This line of code creates an adventurer. It does that because it called the class, and the class is called adventurer. It's like calling a function. It's going to go to the class and create an instance of what it means to be an adventurer. And then it assigns that to a variable that we've called BIF. So BIF now is a variable whose value is adventurer. Its data type is adventurer. We can make a comment. BIF is a variable. It was assigned to be a member of the class we just made. When this new instance was made, Python looks for the special method _init to handle what happens when we make a new adventurer. We did supply such a method. So we expect BIF to have all of the attributes that we want our adventurers to have when we wrote the init method. Let's check. First, if we imprint the type function, sending BIF to it, much like we could send a string to the type function and Python would recognize that it is data type string and we can print it, we can see what kind of data type BIF is. And I probably spelled something wrong, so I'm going to copy and paste to get the spelling the same there, and rerun, and we can see that the type of data that BIF is called an adventurer, and it recognizes it as a class of type adventurer. BIF has the attribute health. So if we use the variable that stands for our adventurer and then put a dot and an attribute name, then we are calling a piece of that adventurer, an attribute of that adventurer, specifically health. And we can see that what was reported or printed was 100. Because when BIF was made to be an adventurer, it assigned that attribute health the value 100. BIF also has two other attributes we can check. We can print the skill and items of BIF in this way. And running it shows us BIF's attribute values. And a comment. Yep, BIF looks like an adventurer. Notice how we reference the attributes. We started with the variable name, then a dot, then the attribute name. Let's make a little adventure for BIF. And the adventure that was made with our adventurer was pre-coded. Let's uncomment it and provide some explanation. BIF has an attribute called health, and that has a value that we've confirmed is 100 right now. As long as it remains BIF's health is above 0, then we're going to iterate this while loop. The while loop will use random to assign role to be a string in this list of victory, defeat, and doldrums. It will use random to assign reward, something at random from this list, gold, friendship, vegetables. And then it's going to do something based on these results. If the role is victory, then we're going to use the append function to append BIF's items, which is an attribute. It's an empty list right now. We will add whatever the reward was if the role was victory with the append function. Otherwise, if the role was defeat, then Biff's items, which is again a list, if there's anything in it, then it will use the pop function on that list. So we could imagine that if Biff met defeat on an adventure, and had something in Biff's list of items, then it would pop it out, which means that it removes the last thing in that list, if there's anything at all. Also, in this code block, Biff's health will go down by a random amount, between 30 and 59. Otherwise, if it's not victory, defeat, we have doldrums, Biff's health goes down by a little bit. And then we check if friendship is in Biff's items, is in Biff's list. And if it is, we break, meaning we break out of this while loop. After we're finished with the while loop, we check Biff's health. If Biff has greater than 0 health, then we print survived and then go through the list of items, iterate through the list of items, printing them. Otherwise, if health is going to be not greater than 0, it's 0 or negative, then we print Biff did not make it. Let's see the result of running Biff through an adventure. We got Biff did not make it. But these are random, there's random results in here. So if I choose to run again, we can see that Biff survived with just friendship. One more test, and again, Biff survived with friendship. This code is working with Biff as if we're thinking of Biff as an adventurer with health and items and skills. But we didn't make use of the skill attribute in this code. We could have made our code more robust, more complicated. Let's define another class that is just a bit more sophisticated than the adventurer that we had created. Another example in use of a class. This class we'll call sailing ship. So class keyword followed by a name, which is capitalized. Parentheses and a colon, much like the definition of a function. We're going to define the function _init, and we're going to use self. Self has a special use and was explained before, but we'll need to review that concept of what self is and how Python uses it. This init function is going to take more than just self. We're going to pass variables name, bigness, and color as well. I'm going to write the attributes of what it means to be a sailing ship. Name is an attribute, and it will be set equal to name, which is passed in the argument of the init. Self.size will equal bigness, which is also passed in the argument of init. Self.active, a third attribute, will be set equal to the Boolean value true. Another attribute called cargo will be set equal to a list, but not empty. It will have the string rope in it. And a fifth attribute, I suppose these sailing ships are not modern. We have an attribute cannons set equal to 3. There are some things to note about the attributes and the init function that are a little bit different and more sophisticated than our adventurer. Notice that we're passing information to the init function. The init function does use this information. Name and bigness are values that are assigned. Notice that the attribute size does not have to be the same variable or the same name as the value that was in the argument or that it is assigned to. It's typical if you want an attribute to get a value from the argument, like name, that they have the same name, that the attribute called name is equal to the same variable that it's getting its information from. But it doesn't need to be that way. I made bigness purposefully different than the attribute that takes on that value. Also, color was passed, but not used. As an example, that can be done. You can give more information and not have to use it. It's inefficient coding, but it's not going to break anything. Let's make a few sailing ships. I'm going to set a variable equal to a call to the class sailing ship. But I'm going to put an ing in there so it matches what I'm saying. Ship 1 is a call to sailing ship, but when I do, I now need to supply the variables that it expects: name, bigness, and color. And notice that I didn't include self. That's kind of special, and we'll provide an explanation of that. So if I'm going to make a sailing ship here, I call the class by name, and I need to send the name that will become the ship's name. I'm going to call this one the 2T2, which is a string. I also need to send bigness, which will become the value that I send for bigness will become the value of the attribute size, and color, which is not used, but it's an example of sending information that doesn't need to be used. I'm going to copy and paste and create a different sailing ship. So I have ship 2. It's going to have the name Troubledore and a different value for its bigness and a different value for green or color. The value is green. And I'm going to make one more ship. The power of classes is that we can make as many instances as we wish. In this case, we're making 3 instances of our sailing ship. Different name, different bigness, different color, and some notes. Note that information was passed when creating the instances. The init function, or the init special method, expected it. We wrote it here to expect it. Notice that some attributes used the passed data. Color was passed but not used. And the attributes did not have the same name as the variables in the argument. In other words, there's an example of this not needing to match. The value comes in as bigness, is used as bigness, but then is assigned to the attribute size. The attributes have many data types, and some are set a value that was not passed during creation. So all of these attributes need to have values. Some were assigned at the inside the init function, and some of those values came through the argument. But what about self? Notice that it's in the init argument, but not sent when we made a sailing ship. So even though self is in the argument in the definition, and it needs to be, when we created the sailing ship, we only supplied the last 3 variables, and self wasn't included, or it didn't look like we included it. This is different than functions. Sailing ship is not a function, it's a class. More on the comment that is written. Well, it was sent, but we can't see it. Self represents the instance that the class and its methods are currently working with. When we use the sailing ship class and its methods, we do so in reference to one of its instances. Python keeps track of which sailing ship and refers to it as self. This is done automatically, so we don't have to actively send the sailing ship itself inside the argument parameters. This is a big difference between functions and methods. Methods always work on or work with an object, and functions work with only what you send them or nothing at all. Subtle but important difference. Let's do something with our ships. So I'm going to write the code, and I have comments here of what I intend to write. We're going to do something with our sailing ships. We're going to iterate through the ships to find the largest size. Size is an attribute. And then we're going to find which ship had the winning size. So let's do those three things. What are we going to do with our ships? Well, first, to help iterate, we're going to put our three ships inside of a list. Our three ships are ship 1, ship 2, and ship 3. Don't want to make a spelling mistake when spelling ship. And we're going to say, we're going to assign this idea of hull, which is the size of a ship. It's the body of a ship. And we're going to assign it an initial value of 1. And we'll see what we're going to do with that. We're going to iterate through the ships and find the largest size. So we have a list of ships, and we can use a for loop to iterate through and use the iterating variable ship in our list of ships now. And each ship that we iterate is going to be used in a condition if we look at its attribute size and compare it with hull. The condition will be true if it's greater than our current value of hull that we first assigned to be 1. And if the ship size is greater, then we redefine hull to be that ship size. So here's what this code is doing. We have a collection of ships in a list. We go through that collection. We start with a hull value of 1. Now all of our ships have a size that is greater than 1. So this list will take a look at the size of the ship, compare it to the current hull size, and if the hull size, the current hull size is less, then we reassign that hull to be the ship's hull size. And if we keep doing this, what's going to happen is we're going to, the final value of hull will be equal to the largest value that we found of size in our ships. Maybe it's easier seen than said. Now, if hull belongs to the largest ship, we need to find which ship had that size because that's the winner. So we're going to iterate through our ships again. For ship in ships, if the size of that ship, which is an attribute, so it's ship.size, where ship is our current object of sailing ship that we're working with, if it is equal to what we've discovered to be the winning size, the value of hull, then we're going to say that the winner, a new variable, is equal to that ship. And if we've found our winning sized ship, we can break. We can stop iterating. We don't need to check the others. We know that they're going to not be the winners. And then finally, now that we've identified the winner as the ship, then we're going to print the result. The %s is a string, and we will use the attribute name to fill that space, which will then report to the user the name of the ship that is the winner because it must have the greatest size. Let's check. We're going to anticipate that the ship's name that should be the winner is the one with the greatest size, and that is the Catan. So when we run, if our code works, we should expect it to print the Catan is the winner. A little bit of comments about what we just did. Notice how easy it is to assign all of what it means to be a sailing ship to be simply the values of a variable. In other words, when we made our ships, we assigned all of what it means and all the values of the attributes of a sailing ship to a single variable. So the variable stood for all of that information. This is just the cherry on the tippy top of the iceberg that is the power and capability of classes. Much more to come. Now you. You have seen how to write a simple class that makes use of an init special method to make a few instances. Write your own simple class that includes at least 2 attributes, one of which must get its values through the init argument. Make at least 2 instances of your class and confirm in your code that you can report a value of an instance attribute. So I want to show you the pieces of this example that are being asked to be done. In other words, make your own class. Choose a couple of attributes. Write an init special method to be a part of your class. Have at least one of your attributes get its value through the argument. Like name gets the name attribute is assigned the value that came through the init argument. Then make a couple of instances. We made 3 here. And confirm that you can access or print or see an attribute, a value of an attribute of your class in some way. It's up to you. For example, we printed the name attribute of what we discovered to be the winning ship. Have fun.